6-4, dealing with rhombi and squares. Yes, it's not rhombuses. The plural is rhombi, kind of like cactus and cacti. And then squares is obviously the plural for square. We're once again going to take a look at the characteristics of the rhombi and the square and see, what's specific to the rhombus and what's maybe just a parallelogram, what's just a rectangle, and kind of look at, what are some of the characteristics that we might want to keep an eye on as we go through dealing with the rhombi. So the opposite sides are to be congruent and parallel. Once again, you have to think, is that new or is that something that we've already heard? Congruent and parallel, that's basically making it a parallelogram. So, but it is still a property, and so we should keep it in mind. So there we go, congruent and parallel. You may notice something a little bit different about that than what we've had before, and we'll talk about that once we get there. So we'll see what happens. Sorry about the pause there. I had to go take care of something. But back we are to our characteristics of rhombi. Second one, ooh, it's small. Opposite angles must be congruent. Okay? And we know that from earlier. We know that basically whatever we put here in that angle better be the same down there, and that one better be the same there. Okay, and you can add this stuff as we go through the picture or not. It's completely up to you. That's just a parallelogram. That's not necessarily anything new. And I think we know at this point, and you probably don't want to put this in because it's going to get really, there's going to be a lot of stuff in here, but that's 120 degrees right there. That one also has to be 120. And something at this point that you also know that then that would have to be 60, and so does that. And so that's not a whole lot of news to us. We kind of knew that already. But then again, we are very smart. Let's see if this one's a little bit longer here. It's consecutive angle supplementary. Oh, I think that's what we just did. We had 120 and 60, 120 and 60. They were all supplementary. Again, remember, if I gave you a quadrilateral where the consecutive angles were supplementary, though, you are not guaranteed it's a parallelogram because it could be a trapezoid. But if I give you a parallelogram, you do know that the consecutive angles will be supplementary. So far, nothing too new here. This is all basically parallelogram. Okay. Number 4. Diagonals perpendicular and bisect each other. There's definitely something new in there. New specifically to the rhombus is that they are also perpendicular, which of course means what? Yes, exactly, forms right angles. And they bisect each other. Well, that we already knew from the rectangle. They would bisect each other. Okay, so the rhombus here has some similarity to the rectangle, but not necessarily all parallelograms are going to do that. But the rhombus, they will actually bisect each other. Actually, no, the parallelogram, they will bisect each other. It's congruent, that's the rectangle. Okay, and so if we take a look at that, oops, do that. I do that a lot, though. You think I would learn? So there's your perpendicular, and they bisect each other. As I told you, this was going to get a lot of information in there. For example, if that's 5, that's 5. If this is 10, that's 10. Things like that. Once again, we already knew most of that. But new to the rhombi, is that they are perpendicular for sure. And of course, all 4 angles on the inside there would be perpendicular because of vertical angles and supplementary. A 5th one. And if at any point this gets going too fast, you can always pause it just by tapping the screen. Diagonals bisect a pair of opposite angles. This one is new. All right. So that's why I'm going to get rid of this. And what that means, again, what did we have down here? We had 60 before. What that means is that's going to get bisected. So each one of those, if it was 60 to start with, would be 30. And these were 120 before, so if it gets cut in half, these are each going to be 60. And again, these will be each 30, because it has to match the one over there, remember? And then this would be 60 and 60. Okay, and that's if you knew that the angles were 60 and 120 to begin with. But we do know that it bisects it for sure. So that one gets cut in half, and so does the other one. Okay. Obviously, if it was, say, 50 and 130, it would get cut obviously a little bit differently. But this is definitely new to the rhombus. Those angles getting cut in half is new. And one that most of you probably know, the sixth one, and actually is already on the figure that we kind of did when we did number one, that the opposite angles were congruent and parallel. You may notice that if you look at all four of the sides, they only have one tick mark on them. That is not a typo. That is because in a rhombus, all four sides must be congruent. So you can see right here, I put that same tick mark, just one in all of them. So, if this one's 15 up here, then this one's 15 there, and 15 there, 15 there, so forth and so on. And so some of the key stuff that you're going to want to know about a rhombus is that you do have here a bunch of right triangles. And so if I gave you a side and say I gave you this one here as 5, you should be able to figure this other piece out because it's a Pythagorean theorem, right? That's just a right triangle. You can use Pythagorean on that. And if we expand our search a little bit wider here, then this triangle here, it's not a right triangle, but it is isosceles because you get the 15, the 15, and so then those base angles have to be the same, but we knew that already, but it's just another way of looking at the figure. Okay, so kind of like when we started talking about some of the other stuff, we were learning there's a lot of triangles floating around inside here. So there are your 6 main properties for the rhombus, and then again, this is at this point specific to the rhombus. Again, any questions I can address when I return. All right, now we're going to talk about the square. Many people, when they start thinking about a quadrilateral, think about squares as being the most in general, but actually it's one of the more specific. It's kind of a combination of many of them. In fact, it's the combination of the rectangle and the square. If you take all the properties, kind of put them all together, you get the square. It doesn't work necessarily the other way. Okay. So the first one here, oops, I thought I fixed that. The first one here is that opposite sides congruent and parallel. Well, that's nothing really new to us. We knew opposite sides were going to be congruent and parallel. And there they are. Okay, so nothing overly exciting there. That's just any old parallelogram. Okay. Second one, opposite angles congruent. Once again, no big surprise there. In fact, you know more information than that. And we'll get to that a little bit later. But again, that would just be any old parallelogram. Third one, consecutive angles supplementary. Once again, you knew that because this is a type of parallelogram, so we knew that was going to happen. And then again, we're a little bit more specific in our knowledge. And I think starting here is whenever you're going to see this is kind of the rectangle and rhombus put together. The diagonals are congruent, perpendicular, and bisect each other. The congruent part basically comes from the rectangle, perpendicular part comes from the rhombus, and bisect each other comes from the parallelogram. Okay, so it kind of gets pieces from all of it. And so that would look something like that. And you're probably looking, we got some right triangles again, we've got some isosceles triangles again. In fact, multiple isosceles triangles in there, depending on how you take a look at it, and those will be congruent by various means, side, side angle, side, all of those. And this one here, diagonals bisect a pair of opposite angles. That comes from the rhombus, which we just learned a few minutes ago. And in fact, we again know a little bit more information this time, and we're going to get to that towards the end. Again, it's probably the one most of you already know about the square. Other than that, all the sides are the same. And then we'll talk about these in the figure as we get done. Once again, all 4 sides are the same. It gets that basically from the rhombus. It's not that the rhombus gets that from the square, it's that the square gets it from the rhombus. Again, it gets going too fast, just tap the screen, not a problem. And then just tap it again to get started. All four angles are right angles, and that's probably, obviously that comes from the rectangle. And so we better not use red, we'll use green here. So we know those are all right angles. And so if we also know they're bisected, we also know that basically each of these little ones in here are 45s. Okay? And so I could go around and do that. But again, the supplementary still makes sense because we have 90 and 90, opposite are still congruent. We still have all of that information. But what you want to probably start looking at is the various types of isosceles triangles you have. For example, we have these, and in fact we have 4 of them that are just like that here, right? And so keep that in mind, that those are all going to be the same in isosceles. Okay? And we know those have to be the same, and in fact we know they have to be 45 because we know that's 90. Okay? And then also take a look at this one. This is also isosceles because those are the same. And again, you know, these are the same, and this is a right angle. Okay, and that's going to be the same. There's actually 4 of those as well. Okay, some of you might not see all 4 at the moment, but we have this one that you can see right now. And then another one that's exactly the same, and probably the one that some of you are missing is if I do that one, that's the same triangle, and I can keep just rotating around and keep making them that way. So don't necessarily look at them as just quadrilaterals, or squares, or rhombi, or parallelograms. Start looking at the triangles that make them up. Okay, so hopefully that's been enough time for you to get down those properties and kind of figure out, you know, what's specific to each one. Here's your square, you know, and then back here is your rhombi, and so like what's kind of important on each one. So it says here, use the rhombus. We have to only think about rhombus properties here to determine the missing values. So you may need to flip back and forth on your page here, but let's go ahead and see what we can do. Angle 1 here, it says, is 2x plus 10. And angle 2 is 5x minus 14. What I have seen some people do in the past is they set basically the 2x plus 10 equal to the 45 because they just saw the square. But we don't know this is 45. That could be any angle up there for angle 1 pretty much. And so we have to be very careful. We do know that angle ABC up there does get bisected by segment DB, but we don't know what either one of them specifically is. But if it does get bisected, like it says for the rhombus, then that angle there has to be equal to that one, or congruent. And so in this case, we can actually set the two equal to each other. Okay? And probably, again, the way I like to do it is subtract the 2x to keep the variable positive, right? And so then we'll slide over here, kind of do a work area. So 10 equals, basically 5x minus 2x is 3x minus 14. I can keep in mind you could divide by 3 if you wanted to right now, but probably not a very wise choice. So let's add 14. So what we got there? 24 equals 3x, and we're going to divide by 3 then. And so x is, in this particular problem, 8. And it's always good to check. Put 8 back in. 8 times 2 is 16, plus 10 is 26. 5 times 8 is 40, minus 14 is also 26. And so we are good there. We don't have to worry about that. It works out properly. Okay? And so I'm going to erase this. Hopefully you got that down so that we can work on the next one. So this one says that AC is 20. So that one right there is 20. We'll just make a note over here. Then determine AE is the question. Well, that's pretty straightforward because we know that these bisect. And so that one's not overly difficult. AE does have to be 10 because it would be, 10 and 10 to give you the 20. This next one is a little bit more difficult. It may be scary for some of it because you see the square, but no need to worry about that. We'll just put it in there. It says it's y squared plus 54 in there for angle 3. Again, we have to remember we are talking about a rhombus, and so we have to use only those properties. But in a rhombus, we do know the diagonals are bisecting, and we also know they are perpendicular. Very good. And so we know that y squared plus 54 in this problem better equal, well, whatever right angle is, which is 90. So subtract 54. Y squared, because these cancel, equals 36. And here's where you have to be careful. How do you get rid of a square? Okay, very good. Square root. And so these cancel over here. So y equals, now here's where you have to be very careful. Whenever you decide to kind of take the square root throughout a problem, you do have to add the positive and negative out front. So positive and negative 6. And there they want us to power off, so you can tell that I'm doing this after school. And hopefully I picked the right one. So click to cancel. So yes, cancel. So positive and negative. And the reason is that if you put positive 6 in, positive 6 squared is actually 36 plus 54 is 90. Put negative 6 in, and it also comes out to 90. So they both actually work. And realize sometimes in geometry they won't both work, but this time they do. Yeah, you can field any questions if you want to return, but I think you should probably be able to handle those. Those are, again, using the properties of the rhombus. And again, if you get a problem that's a square, you should use those properties. You have another problem on your assignment there. It says determine whether it's a, at least I believe you have it on there, it gives you a bunch of points and determine if it's a rhombus, rectangle, or square. Probably the easiest way is to graph that and maybe start looking at lengths and slopes and things like that. Same, or even look at the diagonals and things like that. Some of the same strategies you gave me previously. What I would like you to do right now is to take a moment or two and kind of write a yes or no on each of these cells right here. And basically what I'm asking you is, does it have to happen? So for example, in a parallelogram, do the diagonals bisect each other? Do they have to? Do they have to? Every single parallelogram out there, do they bisect each other? Yes, they do. Okay? And so go through there and put yeses or nos through there. And take a second. Obviously, I'm going to pause the recording here. And so please pause it as well here. Just tap the screen and you can tap it again when it is time to go on. All right. So hopefully you took some time there. And basically here's how it goes. The rectangle, well, if you said yes for parallelogram, if all of these are parallelograms, you're going to say yes for all of those. Diagonals congruent is a, I'm just going to go to n and y's now, if you don't mind. I'm running a little short on time here. And this one is no, no, yes, yes. And once again, no, no, yes, yes. Okay. And so again, if you have any questions on those, I can definitely field those. But it's very important for you to know which properties go with what. You will see a table similar to this on your test. In fact, it'll be a little bit bigger. And so you're going to want to get very familiar with these properties and know what object has what. So hopefully that was enough time for you to get that information down. If not, you can always get it from a neighbor or watch the recording another time.